Dear aspirants, welcome to my channel. This is an concepts of electrical circuits. So model question paper 3. These are the 10 marks question. So what is the data is given? The capacitors as given here, which is the three capacitors as given, and also an volt as given. DC. So to find the equivalent capacitance and total discharge stored in the energy. So first we have to write down the given data. So given data as capacitor C1, C2, C3 and volt as given. So we need to find out equivalent total capacitance. So equivalent, okay, capacitance we have to write down. So E equivalent, I'll write the formula capacitance. It is connected in series. So you can write down 1 C equivalent is equal to 1 divided by C1 plus 1 divided by C2 plus 1 divided by C3. So 3 capacitance has given. So just substitute in this equation. So 1 by 4 plus 1 by 5, 1 by 6. Now you have to take a LCM of this. So if you take an LCM of this, so you will get a LCM is 60. Okay, 60. So if you do the calculation, so you will get final answer. I'll write it. So you will get, if you do LCM or LCM, if you do, you will get a 15, 12, 10 divided by 60. So you will get 37 divided by 60. So if you do the cancellation, so you will get 1.62 microfarad will be an equivalent capacitance value. So we need to find out the total energy and total charge. So total charge, so that is total charge. So you can represent Q. Q is equal to C equivalent capacitant equivalent into V. So this voltage as given, C we have calculated 1.62 into voltage is 100. So you will get 162 micro capacitance will be an answer for total discharge. Next is energy stored. So energy, I'll write, next is energy stored that you can represent W. So W is equal to our formula of into C equivalent V square. So substitute in here 1 by 2, 1.62, okay. Capacitance you have calculated 10 raised to 6 into 100 square. So you will get the final answer is 8.1 into 10 raised to minus 3 joule. Also you can write it in terms of decimal. This 3 come this side. So 0.0081 joule also answer. This will be the answer for this. The next question, to find the magnitude circuit, flux as given, MMF as given, and calculate the reluctance and permeability of the material, cross section as given, length as given. So we need to find out the reluctance and permeability of the given problem. So given data we can write. So given data flux is phi is 0.01 WB and MMF as given. So write down MMF 250 80 and cross section area as given, A as given 5. So centimeter, I will write it 10 raised to minus 4 mm meter square, and length as given, it has given in centimeter, I will write it in meter, all are in meter. So I will write 0.2 meter. So I have written centimeter in terms of meter. So now we need to find out the formula. We have formula, I will write. So first is we need to find out reluctance. So reluctance you write down, that is R. Okay, so we have formula for that. R is equal to mmf divided by 5. It's given in the problem. Mm is 250 divided by 5 as given 0.01. So you will get 2000 25,000 AT divided by WB units. This will be an answer for reluctance. So we'll move on permeability. So next is permeability. Permeability is equal to, so L divided by reluctance into area. So L is given 0.2. So reluctant is 25,000 we have calculated. So area is 5 into 10 raised to 4. The final answer you will get 0.016 H by M will be an answer for this question. The next problem is, so RCL circuit as given, volt as given, okay, frequency as given here, and R is resistance, length as given, capacitance as given. We need to find out XL nothing but inductive resistance, X is inductive capacitance, Z nothing but impedance, I nothing but current, and power we need to find out. So first we have to write down the given data. So these are the given data. You need to write it in the exam or in your booklet. Next we'll find out XL, nothing but inductive reactance. Inductive reactance nothing but XL. XL we have formula 2 pi F 2 pi FL. So if you substitute here 2 into pi value as it is, so F is given in the question 50 Hertz and L is given 0.2. So you will get 62.8 ohm will be an inductive reactance. So we'll move on. XC capacitance, inductive capacitance. So inductive capacitance nothing but XC. If you know the formula, it is very easy. 1 by 2 pi FC it is. Okay, FC capacitance. So write down 1, 2, pi value. You will get it in your calculator. F is, that frequency is same as 50 into capacitance as given 100. So micro is given 10 raised to 6. The final answer you will get 31.8 ohm will be an answer for this. Next we'll go to the impedance. Next is impedance Z. We have formula for that. Z is equal to R square plus XL. This is XL minus XC whole square, that root. If you do substitute, R has given, resistance is given. So I'll write it directly. Root 10 square, this is square, plus XL we have calculated, XC and XL we have calculated, substituting here 62.8 minus 31.8 whole square. So if you do the simplification, if you do this this minus, so you will get 31 square, you will get it. So I'll write it, okay, 10 square plus 31 square root of this. If you do, you will get 32 point, this is 2.6 ohm will be an answer for impedance. Next is an current. I is equal to V by Z. V has given 230, Z you have calculated, so 32.6. So you will get 7.06 ampere. Next is power factor. So that power factor we are representing cos phi. So cos phi is equal to R by Z. So substitute 10, Z is 32.6. So you will get 10.31. So you can represent lagging. So this will be the answer for this question. We'll move on to next question. So in this question, is a three-phase 400 volt as given. The balance delta is connected to load is 20 ohm per phase. Find the phase voltage, phase current and line current and total power consumed. We need to calculate. So in the three-phase delta, so what are the data as given here? Okay, write down that in a three-phase delta. So line current, what is given? The line current, the three-phase, the line current, that is voltage as given. You can represent line voltage, so that you can represent VL is 400 volt and resistance as given R is 20 ohm. Okay, phase voltage. Okay, for here in this case, phase voltage is equal to phase PHL, right? Phase voltage is equal to line voltage will be same, that is 400 volt. The first question you got the answer. Phase voltage is equal to same as of line voltage. So next we need to calculate phase current. The phase current is IPH. IP is equal to VPH and R. So VPH already. The line current is also phase current. So is given 400 divided by 20. You will get 20 ampere for phase current. Next we have to calculate line current. The line current nothing but IL. IL is equal to root 3 into IPH means phase current. So 1 point root 3, if you do 1.732 multiply by 20, so you will get 34.64 ampere. Okay, this will be the answer. Next we'll move on to total power consumed. The total power we are representing P. P is equal to root 3 VL IL. Okay, line current and line voltage. So root 3 you can write is, or root 3 you can write 1.732 you can write into 400 into 34.62. So you will get the final answer is 24,000 watt. Also you can write it this. So I'll write it here. So you can write it 24 kilowatt also you can write. Okay. If the content is useful, please subscribe my channel, share and support. Thank you. And keep watching my video.